Hello everyone. Topic we are going to cover right now is the view seriability. Okay. So, what is the view seriability? View seriability of a schedule is defined by the equivalence to the serial schedule, that is a no overlapping transactions with the same transaction, such that the respective transaction is in the two schedules, and she schedule read and write the same data values, that is the view the same data value. Suppose that the schedule S1 and S2 are view equivalence if they have satisfied the following conditions. Okay, so which are these conditions? We will see now. So once again, I will explain. A schedule is view serializable when it is view equivalence to a serial schedule, and all the complex serializable schedule are the view serializable, and the view serializable which is not complex serializable contains the blind write. Okay, so the two views equivalent schedule S1 and S2 should satisfy the following conditions, and these are the which conditions. That is, the first condition is the initial rate. Okay, initial rate. So under these conditions, the initial rate of both the schedule must be in the same transaction. Suppose two schedules S1 and S2 are there, and in this schedule S1, if the transaction T1 is reading the data from A, then in the S2, transaction T1 should also read A. Okay, and the two schedules S1 and S2 are view equivalence because initial read operation in S1 done by T1, and in S2 also it is done by the T1. Next one is the update rate. Suppose in a schedule S1, if the transaction TM is reading A, which is updated by the transaction Tn, and then in S2 also. So Tm should be read A, which is updated by the Tn. So the two schedules are not view equivalence because in S1 transaction T3 is reading the A updated by the transaction T2, and in S2. So transaction T3 is reading A, which is updated by the transaction T2. So this is the updated rate, and the final write is what? Suppose A final write be the same in the both the schedule. Suppose in the schedule S1, if the transaction T1 update A in the last, then in the S2 final write operation should be also done by the transaction T1. The two schedules is view equivalence because final write operation in S1 is done by the T3, and S2 also final write operation is done by the T3. So these are the three conditions must be satisfied for the view serializability. So I will take one examples on the basis of it will clear this theoretical point. So this is one example. So three operations are there. You have to check whether this is conflict serializable or not. Okay, so to prove these things, you have to first find out the it's a precedence graph. Precedence graph means what? Through this precedence graph, it will find out the dependability of each and every transactions. So this dependability graph is like this way. We have already many times we have covered this things how will to draw the this precedence graph. That is a first RA is there. Okay, RA is there. Transaction T1 is performing the reading operations on variable A, and after this T2 is performing the operations on the same variable, that is the write operations. So arrow will be go from the T1 to T3. So this is your first age from T1 to T3 because T1 is performing its operations. After that, T3 is performing the operations. Then after this, again, which operation T1 is performing the read operations on variable A. Okay, so what is that? And after this, again T3 is performing the operations on the same uh, transactions. Okay, so here the age is like, okay, for wait, that is the T1 to T2. Okay, so this is the T1 to T2. One age is there because T1 is performing its operation. Then after the same variable, T2 is performing its operations. And after this T2, okay, this is the we have to find out the right weight conflict. So after that T2 performing the right operation on variable A, after this T3 is performing the right operations on this. So again there is the transactions between this T2 and T3, T2 to T2 to T3, because T1 is performing its operation and T2 is performing its operation. So this way you have to find out the precedence graph here. So here through this it is there is a loop. Is there any loop? Yes, there is the loop. It means that this loop is represent that there is the conflict is occurred. So suppose we rearrange that particular operation. Suppose we are same operations. This is the same conflict of parallel operations. We are rearranging in some way. This way we will rearrange, and again we will draw the, it's a precedence graph. So after this precedence graph, what happens? We will draw it like this way. Okay. So now there is no graph is available. It means it is the conflict serializability. Okay. So this is one example. Again, we will take one example, another one example. This is our, again, the transactions. 4 transactions are T2, T3, T4, and 4 operations are there. So we will check again this transaction is the conflict serializability or not. Now, for this, what you have to check whether the given schedule S is the view serializable or not. Okay. So what you have to do first, we know if the schedule is a conflict serializable, then it is surely view serializable. And so let us check whether the given schedule is the conflict serializable or not. So first that the first step is to draw the list the conflict operations and determine dependencies between the transactions. So this is what, this is the different conflict operations that determine and on this basis we will find out the dependencies graph. Okay, in the stage 2 we have find out the dependencies graph. So this is the dependencies graph. So clearly there is exists no cycle in the precedence graph. There is not any, no single cycle. Cycle means what? There is no loop is available in this precedence graph. Therefore, the given S is is not a conflict serializable. Is a conflict serializable. Sorry. Therefore, the given schedule is S is a conflict serializable because there is no loop is the existing. So thus we conclude that a given schedule is also the view serializable, because we already covered these things. That is whenever this condition is satisfied, that whenever the schedule is the conflict serializable, then it is surely the view serializable. So that particular problem satisfied this condition. So there is the no cycle precedence graph, and is the given schedule is the conflict serializable. Therefore, we conclude that the given schedule is also view serializable. Again, we will take one example, that is the third one example. Through this example, check whether the given schedule S is the serializable or not. Okay. So again, we will follow the same things. We know that the schedule is the conflict serializable, then it is surely the view serializable. So again, we will find out conflict operations, and on this basis determine the dependencies graph between them. So this is the conflict operations within this transaction. Then on this basis, we will our next step is we will find out the dependency graph. So from this dependency graph, it is found that there is the loop is exists. See, this is the loop. T1 is there and the T3 is there. There is the loop is exists between this transaction T1 and the T3. So clearly there exists a cycle in the dependencies graph. Therefore, the given S schedule is not the conflict serializable. Is not conflict serializable. Why? Because there is a loop existing between the two transactions. That is the transaction T1 as well as the transaction T3. Now, since the given schedule is not conflict serializable, so it may or may not be the view serializable. It may be view serializable or it may be not a view serializable. To check whether the S is a view serializable or not, let us use the another method, that is the blind write. Check the blind write. Okay. So blind write, what the blind write? There is exists a blind write. Yes, there is a exists a blind write, that is a W3A in a given schedule S. Therefore, the given schedule S may or may not be the view serializable. Okay. Again, you have to check next condition, that is a blind serializable or not. So there is the blind serializable, blind write WA, W3A is given in a given schedule. There exists a blind write, that is the W3A. Okay, W3A. So this condition is again satisfied. So now we'll again check whether view serializable or not. Let us another method. Let us derive the dependencies and then the dependencies graph. Again, we will draw the dependencies graph. So again, we will drawing the dependencies graph, and still there is no read write sequence. Now let us draw the dependency graph using this dependency. So clearly there is again exists, this is the next one, dependencies graph. So this is again the dependencies graph. Clearly there exists a cycle in the dependency graph, and thus we conclude finally that given schedule is not a view serializable. Okay. So this way we will find out the view serializable, that particular parallel operation is a view serializable or not.